Welcome to The Explainer. Today, we're taking a truly fascinating journey straight into the mind of Demis Hassabis. He's the CEO of Google DeepMind and, honestly, arguably the leading architect of superintelligence working today. We're going to explore a blueprint that scales all the way from the microscopic mechanics of human biology right up to the vast intergalactic futures of human destiny. It's a massive shift in how we understand the world and how your own future is going to look. And we're going to map the whole thing out for you right now.
Okay, let's dive into this. Here is our roadmap. 1. The architect of superintelligence. 2. Solving biology and disease. 3. Simulating complex realities. 4. Defining true AGI. And finally, 5. The 2050 vision. Let's get started.
Part 1. The architect of superintelligence.
Even from a really young age, Hassabis had this deep conviction that humanity just wasn't making enough progress on the big questions of reality. Things like the ultimate nature of the universe or the origins of consciousness, they were staring us right in the face, yet human minds alone were kind of hitting a wall. He realized early on that to actually answer these questions, we needed a completely new instrument. He doesn't just view artificial intelligence as an engineering puzzle or some economic challenge. To him, it is the ultimate scientific tool. And even more profoundly, he believes that building an AGI is the only way to establish a comparative tool. By creating a synthetic intelligence, we finally have a mirror to hold up against our own biological brains. It's the key to unlocking the deep mysteries of how our own minds actually generate consciousness and thought.
Let's move to part 2 and see how this builds: solving biology and disease.
Transitioning from the philosophical side to the highly practical, let's look at the microscopic realm. Through tools like AlphaFold and the cutting-edge work happening at Isomorphic Labs, the immediate goal of this intelligence is targeting the very root of human disease. Now, AlphaFold was absolutely revolutionary for predicting stable protein structures. But biology is incredibly messy. Take intrinsically disordered proteins, for example. These are unstable, they constantly shift and change shape depending on the context of what they bind to in the body. It is literally a constantly moving target. But AI is now moving way beyond static pictures to actively predicting these complex dynamic shapeshifts. Grasping this dynamic, almost chaotic behavior is the vital key to designing perfectly tailored, clean drug compounds that actually work. Think about what this actually means for a family out there waiting for a miracle cure. If you map out the traditional drug discovery life cycle, identifying a biological target and then figuring out how to design a chemical compound to treat it takes years. Sometimes it takes a full decade of agonizing trial and error in a lab. Hassabis envisions using AI to compress this painfully slow compound design phase down to a matter of months, weeks, or, get this, potentially even a single day. We are talking about taking a 10-year wait for a life-saving drug and compressing it into a 24-hour computation. That is a fundamental rewiring of how human healthcare operates. But finding the drug is really only half the battle, right? Testing it safely in humans still takes years. Well, AI is stepping in here too. Now, human regulations and rigorous oversight will absolutely remain. That's crucial. But AI can drastically compress the clinical trial phase. By accurately predicting toxic side effects in a computer before a single pill is ever swallowed, AI prevents failed trials and directly saves lives. It helps efficiently stratify the exact right patients into the correct testing groups based on their specific biology. Because researchers have much higher confidence in the drug's safety profile from the start, they can confidently jump through dosage steps way faster, stripping years of dangerous guesswork completely out of the pipeline.
All right, part 3, simulating complex realities.
Let's zoom out from microscopic cells to massive, real-world macro systems. AI is beginning to intuitively understand the physics of the world around us. Models like Gemini were never explicitly programmed with the rules of gravity, friction, or momentum. Instead, through emergent learning, literally just by ingesting massive volumes of video data, they developed an implicit, intuitive understanding of physics. It's like a toddler figuring out gravity just by dropping their cereal bowl off the high chair 100 times. The AI just figures it out on its own. It can watch a complex visual scene and accurately predict dynamic outcomes, like exactly how marbles will bounce and fall through a wildly complex track. Which leads us to this massive question. If an AI can intuitively simulate the physics of a bouncing marble or the dynamic biology of a virtual cell, can we simulate the global economy to predict the future? It's a concept straight out of Isaac Asimov's brilliant Foundation series, where mathematics predict the fall of empires. But unlike forecasting the weather or charting biology, the economy is the ultimate emergent system. It relies entirely on the wildly unpredictable, often irrational behaviors of billions of individual humans, complex corporations, and competing nation-states. So the crucial point is that right now, economics is basically a giant social experiment. Leaders make massive macroeconomic decisions, like suddenly tweaking interest rates, and then literally just hold their breath for 5 years to see if they accidentally caused a global recession. The complexity is incredibly high, but successfully simulating it, that would alter the course of human history. An AI capable of simulating this sheer level of economic complexity would allow policymakers to test those massive decisions counterfactually. They could run 1,000 different simulations safely inside a virtual world, mapping out every unintended consequence before pulling the trigger in the real world. Which brings us to part 4, defining true AGI.
We throw the term artificial general intelligence around a lot these days. But where is the actual threshold? When does a highly capable AI actually cross over into true general intelligence? You likely remember the famous moment when AlphaGo played Move 37, a completely novel, wildly creative strategy that blew human Go masters away. But Hassabis argues that is actually not true AGI. Finding a new strategy within an existing game with predefined rules is ultimately incremental progress. True AGI isn't just about winning the game. It's about having the deep foundational creative capacity to invent a game as mathematically complex and beautiful as Go entirely from scratch.
To really measure this leap, Hassabis proposes what he calls the Einstein test. Imagine you build an incredibly powerful AI, but you restrict its knowledge base entirely to everything humanity knew up to the year 1901. Given only that limited data, could the AI independently invent the theory of special relativity, just like Albert Einstein did in 1905? True AGI must be capable of generating truly novel scientific leaps. It's not just about crunching existing data faster than a human. It's about having the raw, imaginative spark to ask a profound question no one has ever thought of before, like independently conceptualizing the dark matter hypothesis without any human prompting whatsoever. Fascinatingly, to actually get there, we might need to look right back at our own biology. Hassabis, drawing directly on his own PhD work regarding the human hippocampus, points out that humans consolidate vast amounts of daily memories and spark creative problem-solving by doing something very simple: sleeping. Current AI systems waste huge amounts of computational storage, holding on to every single piece of context they've ever seen. Future AGI architectures will likely need a literal sleep mode. This would be a dedicated offline consolidation period to elegantly extract only the most useful fragments from a massive day of continuous data intake. It would integrate those absolute gems seamlessly into its foundational model without overwriting its existing knowledge.
Finally, part 5, the 2050 vision.
So when Hassabis finishes his day job as a CEO, he spends his 1 a.m. to 4 a.m. hours just thinking deeply about philosophy, humanity's ultimate destiny, and where this is all taking us. And the milestones he imagines for 2050 are honestly awe-inspiring. Assuming we cross the line to AGI safely and equitably, we enter a post-scarcity world. Freed from the brutal constraints of resource scarcity, humanity can pivot to focus purely on maximum flourishing. Hassabis imagines a future where we take job interviews while living on the moons of Jupiter. He imagines humanity pooling resources to construct Dyson spheres, these massive, mind-bending megastructures built entirely around stars to harvest their raw energy. And all of this is driven by watching a new AI-native generation achieve in a matter of days what used to take massive teams of scientists decades to accomplish. Hassabis echoes this incredibly beautiful poetic ambition from Carl Sagan, stating that our ultimate cosmic destiny is to spread outwards, literally waking up the universe with human consciousness. This deeply profound idea is exactly why he spends those early morning hours tirelessly advocating for international cooperation around AI. We are basically handing ourselves the fire of the gods. We have to safely navigate the incredibly powerful tools we are building today to ensure we actually survive to experience this era. The technology is merely the vessel. Human consciousness is the payload we are trying to carry into the future.
I want to leave you with this final, provocative thought. We are entering an era where you will have access to the ultimate tools of scientific discovery. The barrier to invention, the friction of taking an idea from your brain and making it real, is entirely collapsing. So the real question is, what will you and the upcoming AI-native generation choose to build when fully empowered by superintelligence? Lean into these tools. Be imaginatively daring, and think about your own role in reshaping reality. Thank you so much for joining me on this explainer, and I'll catch you on the next one.